Okay, everybody should have this notes page out. It is integrals as net change. Now, we have already looked at a formula that looks just like this. So we're talking about how things change when you integrate, especially if your original equation is a rate of change already. If you have time in hours here, and you have a velocity that is miles per hour, what does the area under this curve represent in terms of this problem? Okay, what formula do you see right here? Okay, the formula is velocity, this graph is velocity, but this whole formula, the integral from A to B of velocity, we just did that a few days ago. Okay, it is displacement. It is the displacement formula. Okay? But because it is all positive, it is also the total distance formula because there is no left-hand motion. Does that make sense to everybody? So, slash total distance traveled. Okay, now here's my other question. What unit of measure should the area be labeled in? It is miles. Now this is kind of strange. Miles is usually a linear measurement, right? When you measure a mile, it's in a line. But here, miles is actually an area. That's a little bit unusual, but that's the way it works when you're dealing with area under a curve. So this is the total distance traveled in miles. So if you are given a rate of any kind, any sort of velocity or rate of change, and you integrate it, you are going to get a total amount of something that is accumulated over time. Okay? So I want you to write this down. An integral is equal to an accumulated amount. So as you read these problems, I want you to think about accumulated amounts or total amounts of something over a time interval and see how that fits in. Now this problem we're going to look at first does not even say the word integral anywhere, but you need to be able to read it and know that it means to integrate it. It starts out by saying from 1970 to 1980, the rate of potato consumption in a particular country was this function right here, millions of bushels per year, with T being years since the beginning of 1970. How many bushels were consumed from the beginning of 72 to the end of 1973? Okay, so first thing I want you to notice this. It says that the function given is a rate. Now, this is a rate. It doesn't say dy dx. It doesn't say c prime of t. It is a rate, even though it says c of t. Okay, that's very important. The question asks for you to give the total number of bushels over a period of time. So when you are given a rate and you are asked to find a total amount of something, that means you are going to integrate. And this is what I want you to get out of this lesson today. When you are given a rate and you are asked to find a total amount of something, how many bushels, then you're going to integrate to do so. Okay? So, in this case, it's going to be the integral of this function 2.2 plus 1.1 to the t dt. Now, if you're not careful, the limits of integration can be a little tricky. What do you think the lower limit's going to be based on this problem? It is just going to be 2 because t is the beginning of 1970, and it says the beginning of 1972. That's 2. What is the end of 1973 going to be? It's going to be 4. Because the end of 1973 is the beginning of 1974, so it's going from 2 to 4. Does that make sense to everybody? Okay? Now, for the AP exam, they do not want to see you write Math 9. They want to see this. They want to see what you're typing in the calculator, and then they want the answer. This is a completely calculator activity today. So, take your calculator. Sorry, I forgot to mention you need calculators today. Grab a calculator. Are lights still on? Yes. So we're going to do Math 9, 2 to 4. 2.2 plus 1.1 up arrow x dx, just like so. Now I know you didn't type in t's, that doesn't matter. The problem is in terms of t's, so you need to write t's on your paper. And so we get for an answer, I know it's kind of hard to see, 7.066. Some of you lost points on the group assignment because you did not round to the correct number of decimal places. And I've been saying all year, calculus AP requires 3 or more. So make sure you go out at least 3. If you want to write all 8 or 9, I don't care, but at least 3, that's what they grade. Okay, now, look back at the problem. How should I label this? Okay, it looks like bushels, but go back, it says how many bushels were consumed. Do you think that an entire country consumed 7 bushels of potatoes over 2 years? I don't think so. Okay, it says right here that the equation is in millions of bushels, so this is million bushels. And that makes a little more sense. There would be a huge famine going on if an entire country only ate 7 bushels of potatoes over 2 years' time. It would not be a pretty picture. Okay? Do you have any questions? Pretty straightforward. If you're given a rate and you want a total amount, you integrate. That's the key to today.
Is that it?
That's it. We're done. Okay, I know there's a lot of room, but the next page has a huge chart on it, and there wasn't enough room if I left it on the bottom of the page. Turn over to the back. That's really it, seriously. Oh, believe me, they get harder. Oh, believe me. All right. Example 2. A pump connected to a generator operates at a varying rate depending on how much power is being drawn from the generator to operate other machinery. The rate in gallons per minute at which the pump operates is recorded at 5-minute intervals for an hour as shown in the table. So they gave me a rate right there. The question says how many gallons were pumped during the hour. So once again, given a rate, asked for a total number of gallons means we're going to integrate. Given a rate, asking for a total means we integrate. Okay, I got a problem though. I don't have an equation. It's hard to integrate a table. Now, those of you who have taken AP Stats would look at this and say, oh, I'm just going to put it into L1 and L2 and calculate a regression. No, 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 no. Anything like that done on an AP Calculus exam will get you no credit because you're doing stats on a calculus exam. They don't want stats, okay? No regressions allowed, okay? But what I want you to do is answer me this question. On the previous page, we're talking about area under a curve, right? How did we calculate area under a curve if we didn't have an equation? Riemann sums or? Not exactly. What's the other formula besides Riemann sums? Trapezoidal rule. So, if no equation is given, use Riemann sums or trapezoidal rule to estimate the area under the curve. If no equation is given, use Riemann sums or the trapezoidal rule to estimate the area under the curve. Do not do a linear regression. Well, actually, you don't even know if that's linear. Okay? So, there were 3 kinds of Riemanns. There's left, right, midpoint, and then there was trapezoidal rule. Which of those was the most accurate? Trapezoid is the most accurate because it connects all the dots and makes it fit under the curve nicely. So, trapezoids are the most accurate. So, unless the problem tells you to use something else, use trapezoids. If it says use a left Riemann sum, use a left Riemann sum. because otherwise they're going to grade it as you don't know what a left 3 months sum is. So I'm going to come down here and do t equals. Okay. Question. Can I do the shortcut for this, or do I have to do individual trapezoids for every single one? Okay. Well, Alec, why can I do the shortcut?
Because the base goes by the same interval.
Exactly, because the base is the same interval all the way down. Very good. Very well said. Okay, so the formula is trapezoid always starts with a half. Don't forget that. A lot of people forget that. And what is the base? It is 5, okay? I am not going to write all of them. I'm going to write a abbreviated version, but we're going to type them all in the calculator, okay? So we start out by writing the first one, 58, and then 2 times the next one, 60, 2 times 65 plus ... That's enough of those. Which one is the last one that I want to multiply by 2?
63.
The first 63, and then add a 63 on the end and close it off. Okay, now I want to show you something about your calculator real quick that's going to help you. You're going to have to put all of this in, okay? And the one thing that really bothers me about the calculator is the fact that it doesn't text wrap. You know what I mean by text wrap? You ever type something and it just goes off the screen and it just keeps going and you can't see it? That's what the calculator does. But there is a way to make it not text wrap. The only thing is it turns off the pretty integrals. So you need to do it temporarily and then turn it back on. And it's really helpful when you're putting in data to make sure you don't forget anything. So here's what I want you to do. Take your calculator. If you have the new operating system, oh, that's so dark. If you have the new operating system, push the mode key real quick. And I want you to scroll down until it changes screens. And the very first thing it says is classic. Change it to classic for me, please. Okay. Now as you enter your data, it's going to text wrap like it's supposed to. So now start entering that chart. So 1/2 times 5. So you can just type in 2.5 parentheses, then 58 plus 2 times 60. Okay, check with your neighbor and see if you got the same answer. Okay. Now when you're done, just those of you who are done and have a couple seconds to spare, push Math 9 right now and see what it shows you. Doesn't give you that nice pretty integral anymore, does it? That's why you got to change it back. So once you're done, go back to mode, change it back to the math print.
Wait, how do you do the math 8?
On the Math 9?
Math 8. I didn't know how to do math 9.
Okay, Math 8 on the 83s.
Yeah.
Okay, you type in the function first, comma x for the dx, and then comma the number you want to plug in.
Okay, so
Okay.
just like
Okay, this one should come out to be 3,582.5. Is that what y'all got? 3,582.5 what? And this is gallons that were pumped. So there's your answer. The total number of gallons pumped over the hour were 3,582.5. That's a logical answer. Okay? Any questions, calculator problems, etc.? Okay, if you didn't do so already, push the mode key and switch it back right now because you're going to need it back in the other way for the rest of the lesson. Okay? All right, we're done with this side. You have a question?
I
No?
was just wondering, is this a bit on like the not the group assessment that's before that? I feel like this is like
It is kind of, yes, but it's more of a. On those, I usually told you use a left rim on some, use a right rim. But now I'm not telling you that, so you've got to know what to do. That's the point. Okay, number 3. This is the hard one, guys. Okay, this was on the AP exam about 3 or 4 years ago. Okay, and that's why we're going to work through it. What makes it hard? The first time they put one of these on the AP exam, I believe, was in the late 90s, and everybody just flipped out because of the fact that it's got 2 rates, and that's what makes it harder to do. All right. This one is about home heating oil. Now, if you've ever lived any place really, really cold, that's how they heat their houses. Just like your car runs on gas, your heater ran on home heating oil. And it's a lot cheaper to use than electricity as far as heating your home, especially in climates where it's constantly snowy or really, really cold. So a lot of apartment complexes or big buildings, etc., will have a giant heating tank outside, or some of you may even have land where you've got a propane tank. It's kind of the same thing. So oil's going in and oil is also going out at the same time. So it's never a static amount, and that's what this problem is talking about. The problem says a tank contains 125 gallons of heating oil at time 0. Please underline that. The AP exam will never give you extraneous information. You will need this somewhere in the problem. So once you're done, if you haven't used the 125 somewhere, you probably made a mistake. Okay? During the time from 0 to 12 hours, heating oil is being pumped into the tank at this rate, H of T. During the same time interval, heating oil is removed from the tank at R of T's equation. So now we're going to ask you questions about the two of these. One is going in, one is going out, and these are both rates. Question A. How many gallons are pumped into the tank during the time interval from 0 to 12? Okay, stop for 1 minute, talk to your table. See if you know how to set this up. Don't do the math, just tell me what you would do to solve the problem. And write down the equation that you would use to do it. Okay. Kristen, what do you think I'm supposed to do?
I thought that you would use the first equation
Uh-huh.
and the limits of integration from 0 to 12, and then you just put the equation.
Integrate this one, H of T? What do the rest of you think? Is that what you were thinking? Yes, because you're given a rate, you're asked for a total amount of gallons, and it's only asking about in, not out. So this is what you're going to do. That's what the AP exam wants to see as far as setup is concerned. Now, I would rather I don't want to integrate that by hand, do you? Heck no. Okay, so we're probably going to need both of these, so let's take our calculator, go to y equals, and type them both in there. Oh, mine were already there. Oh well, I'm going to type them in again. The fraction bar might be handy. It's alpha and y equals if you want to use it. 2 plus alpha y equals and enter. I'm trying to scoot it over so you can see it better. Okay, are we good? So, second quit, go to the home screen. Type in your integral. So Math 9, if you're not getting the integral symbol, you forgot to switch it back. 0 to 12, y1, dx. And you get, it's thinking, 70.57. Now, because it's 0.8, you can write 0 or 1. Doesn't matter. What should the unit of measure be for this? Gallons. So, 70.5 gallons went into the tank over the 12 hours. That's pretty slow. Okay, that's all right. Questions on A. Okay, letter B. Is the level of heating oil in the tank rising or falling at time 6? Young, question?
Yeah. Oh, wait, never mind.
Okay, I'm going to give you a minute or so to talk about this and see if you have any ideas on what you would do for this before I sit down and tell you. How would you figure out if it's rising or 6? Talk to each other. Okay. Before I say yay or nay, yes or no, and I don't want to take too long, so I make sure I get through this thing. That's what's concerning me. this table was looking at the graph. So who wants to tell me what exactly you were looking at?
We were looking at time equals 6, where the line is greater.
Where the graph is greater, okay? That's okay. Did anybody else look at the graph? I like that. Anybody, how else did you guys think that we might do this problem? Young, what do you think?
We felt like you plug in the sign into both of, like, you integrate both of them into the graph. Like, the integral.
Okay.
is minus the integral is second, and then if it's positive, then it's right, and negative, then it's
That's not the way I would do it, but I'm wondering if it's going to work. What did you get for an answer?
I did it wrong, but like,
Okay.
I messed up the calculation.
You messed up the calculation. I'm going to try it your way in a minute, because that's a very interesting way to go at it. Did anybody else think of anything? Maddie?
Did you just plug it into both equations and see what comes through?
Exactly. That is exactly the way I would do it. Good job. Okay, now first of all, let's talk about this. Young's way might work, and let me talk about why it will. When you integrate from 0 to 6, what are you finding? The total number of gallons that have gone in and out. So he was saying integrate from 0 to 6, that'll tell you how many gallons have gone in. And if you integrate 0 to 6, the other one, that'll tell you how many have gone out. That will tell you the net change, but it won't necessarily tell you which one's going faster. Okay, are you following what I'm saying? But because rising and falling are rate of change words, aren't they? You need to be looking at the rate of change, which is the H and R equations as they are. So what you were talking about looking at the graph, perfect. But what we're looking at is, how did you set your window, Gabby?
Mine is standard, but I set the Y max to 15.
Okay, so let's do a zoom 6 real quick. I'm gonna take a look at this. You went up to 50. What is that at the bottom? Okay. Oh, but this will work. This will work. Can y'all see? Let's go to 6. Okay. This is kind of the same thing as you said about plugging it in. You can either look at the table or look here. This is Y1, and its rate is 5. If I up arrow, Y2's rate is 8. So what does that mean? It is falling because the in number is smaller than the out number. Is that making sense to you guys? Y2 is how fast it's going out. Y1 is how fast it's going in. Since the out number is bigger, that's because the fact that it's falling. Now some of you may not see that real well in the graph. If you go to the table, I think it's a little bit better. Push second table for everybody. Look at the two numbers next to each other, side by side at the very bottom of the screen. The in number is 5.3, the out number is 8.3. Therefore, it's going out faster than it's going in. You see it now? So the rate is falling. So look at graph or table to find the rates. So of 6 is 5.395. R of 6, or can you see what I'm writing? Barely. Is 8.319. And so the level, it has a falling level, kind of writing this backwards, but that's okay. At t equals 6 because why? I know you guys are writing frantically. Why is it falling? Because more oil is being pumped out. Exactly. You have the data to prove it. Okay? So you can just write more oil is being pumped out. That's a good, valid answer. I want to write it a little bit differently. I want to write it in mathematical symbols. Why is it falling? Because what? R of 6 is greater than H of 6. That works too. Either one. And so I'm going to write or more oil is being pumped out.
So how did you find it on the graph when you looked at it?
I just push the trace key and push 6. Okay? Any questions? Okay, letter C. How many gallons of heating oil are in the tank at time 12? How many gallons are there? Okay? It looks like I kind of figured that out already, but that's not the total number of gallons. That's the total number of gallons that what? Went in. So, huh? Yes, this is when we do your thing, exactly. So, when we're trying to figure out how much is right there, we have to look at how much went in and how much went out. So what we're going to do is we're going to integrate from 0 to 12 h of t minus r of t dt. You can put them in the same integral. Okay, now something weird's going to happen when you type this in. Go ahead and do it. Something weird as in if you understand what the answer means, it's going to be a weird answer. So math 9, 0 to 12, y1 minus y2 dx. I'll move this where you can see it. And you get, drum roll please. Whoa! Okay, negative. Why is that weird? Because it's supposed to be gallons. How in the heck am I going to have negative 3 gallons? Whoa, why do I add 125? Oh, that's how much I started with. So this isn't how many gallons are in the tank. Good job. This is what we call the net change. That's why the notes are titled Integral is Net Change. This is how much it has changed from where we started. So after 12 hours, they are down 3 gallons from where they started. Are you following what I'm saying? This is displacement, guys. This is kind of like a displacement thing. So we now need to add the 125 that we started with. So plus 125, and we get 122.026 gallons in the tank. Questions on that? All right. Now, let's round the corner and head home. Letter D. At what time t from 0 to 12 is the volume of the heating oil in the tank the least? Show the analysis that leads to your conclusion. Now, I really would like to do turn and talk time, but I need to get through this, so I'm going to kind of walk you through the whole thing. Volume, okay, the least. What is the calculus term for least? Minimum. Would this be a relative or absolute minimum? Absolute. Why? Because it's a least and it's also a closed interval. So we want the absolute min for the volume. Okay. I don't see an equation for volume on the page, but that's okay. We're going to figure it out. So, when you find absolute min, which you did on the last group assignment, you take the derivative of v and you do what with it? What do you set it equal to? You set it equal to 0, you find out where it fails, and you do the endpoints. Okay, so that's going to be my plan of attack for this problem. Okay, so now I've got to write an equation for volume. Okay, on letter C, this actually calculated the volume of oil in the tank after 12 hours, didn't it? I integrated H to R, and then I added the 125. How would I change this if I wanted the volume at time 6? The only thing that would change would be this right here, wouldn't it? It changed to a 6. What if I wanted 8? Same change? So, the volume at any time in the problem would be the integral from 0 to x, whatever x I want, of h of t minus r of t dt plus the 125 that we added on at the beginning. Does that make sense to everybody? No matter where I start or how far I want to go, I integrate from 0 to that number. Okay. Now, I'm supposed to take the derivative of that and set it equal to 0. So v prime would be the derivative of the integral. That looks familiar. I think we've done that before. Plus 125. So when you take the derivative of an integral, what do? They kind of cancel out, and what changes? T's change to x's. So v prime is going to be h of x minus r of x. Now, what's the derivative of 125? 0. So that goes away. Okay, so there's my derivative, h minus r. And we're supposed to set that equal to 0. All right. Now, back to the calculator. I don't want to do this by hand. I want to do it on the calculator. So, go to your calculator. I'm going to leave it on this side because it seems to be easier to see. Go to the y equals. I want to know about y1 minus y2. So what I'm going to do is I'm going to come down here and I'm going to type in y3, y1 minus y2. In y3, I want you to type in y1 minus y2, just like you put it in an integral. Okay? And that's the only graph I want to see, though. So do you know how to turn off y1 and y2 without erasing them? You go to the equal sign. So go over to the equal sign on y2 and push enter. You've got to leave y2 there, otherwise it doesn't know what to plug in for y3. Do the same on y1. Or I just turned it back on by mistake. Okay. Now let's set our window. Okay, what is the window for this problem? 0 to 12. Make your y's go from -3 to 3. Since we're doing zeros, we want to stay close to the x-axis. Now push graph. It takes a little bit to do it. Okay, for time's sake, I'm going to tell you what those two crossing points are. 4.790 and 11.318. Okay, I know you know how to do zeros. Second trace and 0. But for time, we're going to go quickly. Okay, there's where the derivative equals 0. Does that derivative ever fail anywhere? Do you see any holes in that graph? No. So it doesn't fail, but we do have two endpoints. X equals 0 and x equals 12. So we need to plug all 4 of those in and see which one gives us the smallest answer. So V of 0, what's the volume in the tank at time 0? 125. I already know that. It would be the integral from 0 to 0, which is 0, plus 125. V of 12 we just did in the previous problem. That's 122.026. So now we're going to do V of 4.790 and V of 11.318. Okay? So we're going to do, I'm going to go back and recapture that integral that I did right here. 0 to 12, and I'm going to change the 12 to 4.790. And I got to remember to add the 125. So that's 149.407. Then do second enter and do it again, but change it to the 11 point, whatever that was, 11.318. $120.738. I know I'm going fast, and I apologize. But do y'all see what I'm doing? You can't see my calculator, I'm sorry. It's 0 to whatever that number is, because that's where x goes. y1 minus y2 plus the 125. So which one is the minimum? Yes, 11.318 is the min. Now, what do I want, the 11.318 or the 120? Which one is my answer?
11.
Okay, at t equals 11.318, the volume is the least. I'm sorry?
The work would come to
The work was showing the analysis.